We have that a 1.5 kilogram mass on a spring has a displacement as a function of time given by this equation right here. The general form of a mass in simple harmonic motion is given by this equation. That tells us the amplitude, the angular speed, and the phase angle. So when we find those variables based on this equation, the amplitude is 7.4 centimeters in either direction, the angular speed is 4.16 radians per second, and the phase angle is negative 2.42 radians. So they ask us for the time that it takes for one complete vibration. That's given by the period. The period is 2 pi over the angular speed. With the angular speed is this, the period is going to be 1.51 seconds. Part B asks us to find the force constant. Or the spring constant. So when we solve for k given by this equation of the angular speed, we know the mass and we know the angular speed. When we solve for k with those variables, we find it to be 26 Newton meters. Part C asks us to find the maximum velocity. So that's angular speed times the displacement, and the displacement at the maximum is the amplitude. So when we solve for those variables, we find it to be 30.8 centimeters per second. The last part asks us to find the maximum force acting on the spring. Well, the force is given by k times the displacement, and the amplitude is the maximum displacement, so that will be where the maximum force is at. And then that's given with our variables as 1.92 newtons. The last part asks us to evaluate the equation for the displacement at 1 second. We find that the displacement is negative 0.0125 meters. They ask us to find the velocity at this point. So when we take the derivative of the displacement, we're given the velocity equation. When we evaluate it for 1 second, we find the velocity to be 30.4 centimeters per second. We then find the acceleration. So the acceleration is negative k over m times x, and the angular speed is given by the square root of the spring constant over the mass. So when we take the square of that, we can solve for this equation. That's going to be negative times the angular speed squared times the displacement. When we put in our variables, we find it to be 0.216 meters per second squared. The last part asks us to find the force at this point. Force is given by the negative of the spring constant times the displacement. When we put our variables in, we find the force at that point to be 0.325 newtons. Thank you for watching, and sorry I went over my time.